Hi, everyone. Thank you for being here. Welcome and everything. My name is Caterina. I come from Madrid and I work in doing deep learning over biomedical images. So let's see. First of all, a bit of who I am, because I guess you don't know me. I did a Bachelor in Telematics Engineer, PhD in Computer Science and Technology. I'm now a postdoctoral researcher at UCM in a bioengineering department, and I think I am a bioimage data scientist, but I think it's me and other 4 people who invented this position and this name, so I'm not sure about it. What I actually do is that I work in the AI4Likfe project. This might ring a bell, I don't know. If not, we will explain it later. I mainly do user support and documentation. So yes, I do loads and loads of documentation. I work, participate, and collaborate in the development of zero-code tools, always focusing on open source and fair principles. We will talk about this later too. And basically what I do in my everyday life is to apply artificial intelligence into biomedical images, microscopy images, MRIs, I don't care. An image is an image, and I apply deep learning to it. So this is what we're going to see and cover in this talk. First of all, we've been talking about deep learning and these and images, but why do we actually need it? Then we're going to see which are the challenges that we could really face in artificial intelligence for bioimage analysis. What's the AI4Likfe approach? How are we trying to overcome all these challenges? And then practical solutions for deep learning and tools. We've been also talking about tools and all. I think this is the most useful part of the presentation. We're going to cover a bit more of this in the workshop in the afternoon, and then future directions and challenges under my point of view. I hope this is useful too. So first of all, why do we need deep learning? These graphs that you see here are graphs about the Bioimage Archive. The Bioimage Archive, I don't know if you know it, it's an online repository for biomedical images, mainly for microscopy images. So this is the number of entries that they are, the data sets that there have been during the last years. So one of the reasons why we might need deep learning for bioimage analysis is for the number of data sets that we have available, the number of data that we have to analyze. Doing this, analyzing this kind of, and these amounts of data manually, this can be very time consuming. So in this case, deep learning can be one thing that might streamline our process in analyzing biomedical images. Second thing is steps. I like to put this slide here because it's from 2016. So it's almost 10 years ago. And even though there we were talking about steps in bioimage analysis, task, or what you want to call it, and there were a huge amount of tasks. So that means that every time that we move a long time, we will have to face more problems, more tasks, more stuff. So everything that we need to do, it can be done somehow or sometimes manually, but deep learning may streamline this task. So basically, when we have to analyze a bioimage or biomedical image, we can face it in 2 different ways: using traditional methods, for example, contrast enhancement, filtering, thresholding, edge detection, and all. That it usually works well when our objects are well defined, images are clean, are knitted. But then it may fail when objects, for example, overlap. You have 2 nuclei that totally overlap. Images are very noisy and they are difficult to work with. So in this case, we might move to deep learning methods. We can do many different tasks with deep learning. Some of them might be segmentation, object detection, super resolution, and even batch processing for these data challenges that we were saying before. These work well for very large data sets, as adaptable to different images, to different image domains, to different tasks, but it has some problems, right? We need some training data, we're going to talk about this, and computational resources. The thing is that I don't want you to think that we might use one method or the other. We can use these together and mount what is called a workflow or a pipeline that might require to do several steps to finally analyze your image. And we're going to see this. So here I arrived to my special part of the presentation where I talk about a good friend. It's a friend of mine since we were teenagers. And he's doing his PhD in biology. He's studying how to grow fishes in captivity. So I didn't ask him a lot about this because he's a biologist and I'm an engineer. But one day I went to his house to watch a film together and with a lot of our friends. And I saw in his computer Fiji. And I was like, oh, you're using Fiji? So he told me what he was doing with Fiji. He had these images, which are stained fish eggs over a plate. He weights these plates and he wants to count and measure each of these eggs to study fish growth. So in there, before watching a weird film we were supposed to watch, he started to explain me how was he analyzing his images in Fiji, and I was like, "Oh my god, this is so complicated! I don't even understand it." And I'm supposed to be a Fiji expert or something like this. What are you doing? Let's make a call. So then, holidays finished. We decided to make a call. So he was telling me that he was doing a thresholding, but a thresholding and a lot of different other steps in order to have this thresholding work. And it was so long. And I was like, you cannot continue doing this. Let's see how can we solve it. So I asked him, will it self-post? Self-post is a deep learning model for doing basically cell segmentation, but you can do it over many different type of images. There was a Twitter thread some long ago that was called "Will it self-post?" It was from Martin, a colleague from Czech Republic. So he was asking if it will self-post, and people was uploading images to the self-post tool and see if it will self-post as chairs. I don't know, whatever. So I saw this and I was like, I think it will self-post. Of course, it self-post. This is the image applied in self-post with the tool without touching any parameter, without doing absolutely anything. And he was moving from that image to this in just a matter of seconds. So this is why why we need deep learning. He could be using a threshold and all what he was doing in Fiji, but of course this was much more easy. This was much more faster for him. Now he's super happy about it. So this is basically why we need deep learning, to streamline this process. But of course, this is not always perfect. We may face a lot of challenges within. So a bit of top 3 challenges. First, data. We have loads and loads of data. We have a lot of data sets to analyze and everything. But the problem is that if you want to train a deep learning model, you need to train it having 2 pairs of data, which is the data you want to analyze and a sample output, as an example of what you want to obtain at the output of this deep learning model, so you can teach this algorithm how you want to convert this input from this output. This is sometimes called labeled data, annotated data, or whatever. It will depend on the task that you want to solve. If you want to do a classification, maybe these labels are 1 and 0 per image. This is something easy. But maybe if you want to do cell annotation, you might need manually annotated image of each of the nucleus of your image. And this can be very, very time consuming and needs for domain expertise. Then we have the usability challenges. Deep learning models are not always easy to use. There are a lot of tools, but you need to know how to use each tool, or which tool to use, or which deep learning model to apply to your image under which tool or how. So these can have some computational barriers, knowledge barrier, and can be sometimes a very difficult task. Then we face reproducibility and standardization challenges. This is open microscopy days, right? So I had to talk about this. The problem is that if I'm analyzing chimp's eggs in my house, in my computer at my work, he has to be able to do exactly the same in the same way. And this has to be possible. This is possible through standardization, to metadata consistency and all. And this is something that is not applied in all steps in deep learning, or not in all tools, or not in all models. Sometimes you might get a model and you will run it twice, 3 times, and you won't get the same result each time you do it. So we need somehow ways that every pipeline can be totally reproducible. So now with AI4Likfe, how are we trying to approach this? How are we trying to do this? AI4Likfe is a project that will soon be finished in August this year. So a bit sad about it, but also new things arise. The thing is that AI4Likfe tries to bridge the life science community with the computer science community. So we have people from life scientists that has images and that needs to learn how to run these deep learning models or whatever. And then we have these developers of deep learning models that needs data to run these deep learning models. So here, this is what we're trying to do. Basically, the accessibility of deep learning models is a challenge that we try to face in AI4Likfe because few people train designs or networks. We have some people that will train these deep learning models. Some of these models will be accessible by paper, which means that we don't have access to the model. We have access to the knowledge on how this model was created. If this model is not uploaded, you might have the architecture, but you might not have the actual weights what will be useful for us. Some of these models that are accessible through paper are also accessible through code. And this way we can maybe launch these models. And some are even easier to run because they are accessible through tools. But how can we make this change among these two communities? So we try to do it with 3 different ways. The first one is the bioimage model zoo. It's a deep learning repository for microscopy model, deep learning models applied to microscopy images. We're going to talk about this later, but this is one of the main places where you can find deep learning models for biomedical images. Then we have the Bioimage Archive. We've talked about this in the beginning. It's a repository for datasets. And then we have the open calls and challenges, which is basically projects in which people apply and we try to help them. We are now currently on the 3rd open call, and for example, I've been applied as AI4Likfe member, a project of an institute that they're working with spheroids. So I try to see what do we have, which tools are available in the landscape to try to not only help them, but train them in how to overcome this. So they become fully independent in doing these problems. And also we have the challenges so developers can participate into developing new models for solving one single task. So now that we're here, how we actually do this? So what we do is that we help and participate in the developing of tools, standardizations, and many things. In order to explain you this part of the talk, I've been creating this kind of workflow, and we will go through each of these steps. The first thing that, imagine that you're a life scientist, maybe you are actually a life scientist, and you have some data to analyze. What we will need to do is to first find a deep learning model. Once we have this deep learning model, we will have to use it. Where do we use it? We're going to see this. Maybe this deep learning model is not working as you expected. Maybe it's not working as well as it would for your data. So you will need to do something which is called fine-tuning or retraining, which means to adapt the already trained deep learning model to your new data set. For doing this, you will need to annotate images. So we have the process of annotating images. Once you have annotated these images, you can fine-tune the models. And then we will see also where to seek for help in all these amazing process. First, where to find deep learning? I already spoiled that. The Bioimage Model Zoo is this deep learning repository for fair AI models. First, think about this. I know if you don't know, I don't know if you know the FAIR principles. Let's cover this. But think about deep learning models as well as you think about data sets, tools, and everything. The FAIR principles are that, for example, in this case, a deep learning model should be findable, should be somewhere, should be accessible, meaning that you should be able to access it and download it, should be interoperable, meaning that you might be able to run this deep learning model across multiple software because you might need to adapt your data or yourself to it. And then again, talking about this, reproducibility. You have to be able to use this deep learning model in different softwares and in different places that everyone obtains the same. So taking this, having this in mind, what's the bioimage model zoo? For you, the bioimage model zoo, it's a web page. It's a web page in which you have access. This web page has access to a server storing a lot of deep learning models. What's special about this web page? Not only that it has models, but you can access the model in many different formats. Each model is characterized to follow a certain format, what we call the bioimage IO specs. So these specifications are a set of fields that will tell us many things about the model. Will tell us, for example, which task are they doing, like if it's image reconstruction, denoising, segmentation, whatever, the type of image that they use to train the model, which data set have they used to train the model, is this model used in some paper, is the architecture in another paper, so we will have citation fields. So what we have developed, apart from this web page, is a way of constructing this metadata for models to give the user many information from it. And thanks to this, we are able to do this interoperability among software. We'll talk about it. So this is a life cycle of a deep learning model, the bioimage model too. The model, the developers will develop their model, and then when the model is working, you will have to package it. Packaging here means to adapt it to these bioimage specs. You need to provide, in order to upload your model to the bioimage model zoo, you need to provide certain fields. You need to provide what is called a YAML file with all this metadata that I have explained, but also you need to provide, for example, a sample input, a sample output, so we can make sure that your model actually works as you say it works. And you need to provide cover image and certain stuff. So once you have your model developed, you will need to package. You will need to then upload it to the zoo. It will pass a review process. And then once this model has passed this review from us, you will have your model uploaded to the webpage so everyone can access to it. Everything is open source, it's open to everyone. You can access to any deep learning model in the webpage, and anyone can do it. So for example, if you develop a model and a colleague of yours wants to use it, maybe for reproducibility purposes, this person can upload it to the zoo instead of giving a zip file through Drive, because it might be more interoperable. Then you can deploy this model on different software and even fine-tune it. And then we would start this life cycle again. This interoperability I've been talking about is thanks to all this software. All this software are software that have adhered to the bioimage specs, to these principles, to this formatting of models. So all of these softwares are able to either what is called consume or produce models. When we say consume, is that you're able to run this deep learning model over an image and obtain an output. And when we say produce, is that we are this some of these softwares are able to train a deep learning model and export it directly with the bioimage format so they can upload it to the Zoom. This is an example. So we have each model in the web page. Each model has its model card with all of this stuff. And these are the software that can run these deep learning models. These ones are able to even fine-tune the models and then export them. So this is when we're talking about interoperability, this is what we actually want. Here in this video, you have an example. We have 4 different software. This is the actual web page in which it has a way to test a model directly through the browser on one image. Then here we have BioPy, one of the softwares that is also able to fine-tune a model. Here we have Elastic, and here we have DeepImageJ. These 4 models are at the same time running the same deep learning model over the same image. That means that this model, as well as all the other models from the bioimage model zoo, are totally interoperable. With this, our main goal is that you don't have to adapt to the deep learning model, but but what you will do is to find the software that is most suitable for you or for your data set. That's it. That's what we want. Because, for example, imagine my friend Jim, that he is used to use Fiji, and I try to convince him to use Elastic. That if you haven't used it ever, it might be something a bit difficult. So he will be able to run it in DeepImageJ because it's in the Fiji ecosystem. So you will need to, you won't need to adapt to the deep learning model, but it will adapt to you and your data. And at the end, we will obtain the same result on all different software. So now that you know where to look for deep learning models, where you can use it, you already had a hint about it. So here's just 3 examples on where to use deep learning models. We've seen DeepImageJ and Elastic, but QuPath is also a community partner. So this is an example on how to choose. I wanted to show you a bit how to choose the deep learning model, the software, right? For example, if you are used to use the Fiji ecosystem and you want to mount a pipeline benefiting from all the Fiji capabilities, like doing some pre-processing and post-processing of the image using Fiji, you can use DeepImageJ and you can use deep learning. So this is the way to use deep learning in Fiji. Then if you are used to use Elastic, you can use the image model zoo inside Elastic. This would be adapting to the user, but also you can adapt it to the data. So if you are using pathology images and whole site images, maybe your place is to use QuPath. So this way, again, the focus is to adapt the deep learning models to users and datasets and not to make people adapt to the deep learning models. Now that you have used your model, again, imagine that it's not working as you think it would work, and you might need to fine-tune it. To fine-tune it, you need to annotate images. Where to annotate images? Okay, there's a bit of a spam. We've been developing lately this plugin for SAMJ. We don't even have a preprint yet, so this is still pretty new. It's a plugin for Fiji for annotating images with SAM-based models. Some models are this segment anything model from OpenAI. It's a model that is able to segment stuff from an image with prompts. You give it a prompt and it will segment the object. The good thing about this is that it's called what we call the semi-automatic annotation. Instead of doing a pixel-wise annotation, you don't need to go drawing pixel by pixel your annotation. You just need to give it a prompt. And the good thing is that these prompts, they do not need to be totally manual. You can have these prompts done in Fiji. You can use Fiji capabilities to, for example, take an image, find maxima on the image. For example, if you want to annotate the nucleus, you get 1 point for nuclei and use this as the input for annotating the image. So this is making the process much more efficient. We will see this in the workshop this afternoon. So here's an example of something I did the other day. So very quickly, this is the SAMJ plugin inside Fiji. So I just put it one image. I downloaded one of the models, and what I did was to click inside each nuclei, and it produced this. And it's stored in the ROI manager. You can later export it as already a segmented image, but this is the manually way to do it. You can do it also in totally automatic. This is what we're going to cover in the afternoon. So now we have annotated the images. Where do we fine-tune an image? These are 2 examples. These 2 tools are very similar. BioPy has a GUI, so it might be a bit easier, but both of them for retraining based on Google Colab notebooks. But by the way, I've seen a tweet today in which now it's able that you are able to connect Google Colab through Kaggle, so you might have more computing time since today. The thing is that there is a Colab notebook. Is done in a way that you don't need to program anything. You just need to click and go. And you're able to select your data set with the annotated images, retrain a model, and export it to the bioimage model zoo format. This way, you can upload again the model retrained in the bioimage model zoo. It works very well. The only challenge is that you don't have any programming expertise. Of course, errors might arise sometime, and it might be a bit more difficult for no programmers. And now where to seek for help. Okay, we already had something commented on this because Benedict commented on the Biomagio chatbot. The Biomagio chatbot is a work that we did last year with Weiyou Yang and Wan Lu principally. And it's basically it's similar to ChatGPT, but for bioimage analysis. Saying that, these are my two preferred ways to contact and to seek for help in bioimage analysis. The first one is the Imagery Forum. I hope you all know about this. If not, you should. It's a community forum similar to Stack Overflow for bioimage analysis. So you have experts for free answering your questions. I think that's amazing. And people is very active in the forum. So you might have the answer to your question in questions of hours or maybe 1 or 2 days. It's really nice. And it's people that is really expert on the field. So they really know what they're talking about. The problem is that you might have to wait some days or some hours for it. If you have something that you need to know now, because if not, you cannot continue working today, there's the Bioimagio chatbot. It's a chatbot which has not been retrained for bioimage analysis, but what we built was what we call the knowledge base. Is a set of documentation, API access, books in microscopy, articles, deep learning, and all the documentation from the community partners is almost in the chatbot. That means that instead of retraining the chatbot as the information is retrieved from the chatbot, the source is always truthful. We avoid this kind of hallucinations that sometimes some chats might have. So you will have consulting documentation in real time. Something that you might be careful about is that you will find different solutions to one problem. So you will have to know which one to choose. I have added here the same tip in both of them. Be precise. Always, even when asking a question to someone or to ask it to a chatbot, be precise about what you're asking because it's always much easier to solve your problem. So this is something I did for a talk some months ago that I was looking for an interesting question in the Imagery forum. And I found this one. It's from a girl named Claudia. And she was looking for a way to calculate which was the most focused slice in a Z stack, right? So she got a lot of answers after some days, and she had, she was very successful in her question. It was in the Imagery forum. So I was curious on how the Bioimagio chatbot would answer to that. So I just copied and pasted the question from Claudia. So a lot of this is the question is behind. So here is the response from the chatbot. And we have different methods to do it. And then that some of them are the same methods that were proposed in the by the community. And then at the end, it says, I don't know, you can read it from the back. For further details and code examples, you can refer to the Imagery forum discussion. And this link goes to here because we have connected the Bioimagio chatbot to the Imagery forum. This way, my two preferred ways of consulting documentation and asking questions are joined together. And this is perfect for you because you will have people answering you, and also you will find answers there. And if this question already appeared in the Imagery forum, it will guide you here because always it's preferred to trust an expert. But this way, we have the two ways connected. So now we're arriving at to the end of the talk, and I'm gonna give you a bit of future directions, challenges, and tips under my point of view. So if you use any of these tips, do it under your own responsibility. First, if a classical method works well, stick with it. Tim's problem was that his classical method was working well, but was too low. That's why we had to move with deep learning. But sometimes you can find a classical method, a simple thresholding might work. Don't try to overcomplicate problems with analyzing images. Sometimes this will not benefit your pipeline. Second and third tip are kind of connected. First is that don't fine tune, forget everything I've said in the talk. Don't fine tune models unless necessary. Just focus on what you're trying to do. If a deep learning model is not adapting to your images, try a different one. In the bioimage model too, there are many, many, many models, and some of them solve the same task. Maybe it's for different images. We have the domain in different images that might that might bring a lot of challenges over the deep learning model. So before fine-tuning a model, please try other solutions. And then if you have to fine tune a model, know that this might not always work. And maybe it's your fault, I'm sorry. Check your dataset quality, try to augment it, check if the dataset is balanced, if you have the same classes in a balanced way. Maybe the architecture of the model that you're trying to retrain is not enough. Maybe it's too much and you're overfitting. There are a lot of things in fine tuning that are very specific and might be that it won't work. So be careful with it. Then always seek for help. No dumb questions exist. Really, please. I can imagine that Shim's life would have been much more easier if he had seek for help 3 months before, not after having analyzed hundreds of images using I don't know how many hours. So please always seek for help. Then another thing, which is totally my opinion, annotated should be done by experts. We find sometimes that people in labs is doing annotation of images and they're not experts. The problem is that if you have an error in your annotations, the deep learning algorithm will learn this error as something that will go to the network and this error will be propagated. So we have to avoid these things. Then there's always more than one solution to your problem. It's your responsibility to always choose the most fair one. And then my vision on the future of AI. Okay, I think this is a bit, I don't know. But well, this is my vision on how will deep learning for bioimage analysis will be shaped in the future. And not that long, like I think it's gonna be close. Training models from scratch needs for GPU or access. So sometimes this can be very difficult. And recently, a lot of foundation models, such as the segment anything model, have arisen. So I think that in small labs, not people with having a lot of resources, computational resources, we will move more to fine-tuning models. Like real life scientists will move to more fine-tuning models than training models from scratch due to computational resources, knowledge, programming expertise, and all this. But these can be sometimes somehow tricky. So some concepts that I think that will be more hurt are knowledge degradation and catastrophic forgetting. I love them. They are kind of synonyms, but one is a bit more dramatic than the other. This refers that when you fine-tune a deep learning model, as if it's a foundation model, you can have some parts of the network, like the foundation model is done in order to solve many tasks over many images. If you try to adapt this deep learning model to your specific data set, you might lose information on the process, and you don't want this. We have to avoid this. And how can we avoid this? Through parameter efficient fine-tuning. This month, there's been a paper from Konstantin Pape about doing parameter efficient fine-tuning on the SAM model. Parameter efficient fine-tuning means that instead of retraining the whole network, you will just retrain some part of it. And you will evaluate which are these parts of the network that most efficiently needs to be retrained in order to avoid computational costs and knowledge degradation. Second, model selection. The problem in life scientists is that you don't need to know about all the models that exist, how each model works, and why. So this is something that needs to be a bit more guided. So when developing a deep learning model, you just need this guidance. How we can do it? Explainability tools will shape this field too. If you give some explanation on why a model is working or not, you will find you will find more guidance in your knowledge selection. And also benchmarking a model for different data set, different domains and all will help these reproducibility purposes. And last but not least, greater interoperability in data and models. Again, reproducibility is something which is very important and every day is getting more into the labs. I think this message is getting more seen lately. So for that, we have, for example, for data, the OMSR format that is being most used. And people is adhering more to these formatting principles and adhering to standardized formats in order so everything is as interoperable as it can, right? And then I have to say, of course, that I hope that the BioImage.io format for deep learning models become a standard for deep learning. I cannot forget to mention everyone that has participated in this. I will not say everyone because it's a lot of people from AI4Likfe, from outside of AI4Likfe, but always great science is done by great people and in collaboration, of course. So thanks to everyone. And that's all from me.